Okay, so the first thing we talked about was solving complex equations with lots of different operations involved. The last two parts of your group work are going to be about particular skill sets we need to have in order to be able to move forward. Okay, so the key to remember is that this is not, okay, we're not talking about equations. Distribution starts as a skill. Right? It's an operation we apply. And in fact, it's an operation we already know. Right? We're really talking in distribution about multiplication and extending multiplication to multiple terms. Right? So if we look at our first example here, 3 times x minus 4, what we oftentimes forget to do is realize that this 3 on the outside, because of the parentheses, is designed to be multiplied by both of the numbers. Oftentimes we might have a tendency to say this is either 3x minus 4, or we say that it's x minus 12, and neither one of these is correct. The only correct equivalent expression is to distribute the 3 to both terms and get 3x minus 12. That's pretty simple. We've seen it in other equations. We've used it a couple times without ever talking about it. It grows more complicated when we're distributing terms other than numbers, right? What if I want to start distributing a variable through? So now we're down here to example number 2. Now I want to distribute x times x minus 4. And in this case, I'm still distributing that x to both terms, but now I need to think about what happens. So it's going to be x times x minus 4 times x. And if I remember my exponent properties correctly, x times x is x squared, minus 4 times x is just minus 4x. So x outside of x minus 4 is equal to x squared minus 4x. And this right here, okay, you're trying to figure out what am I supposed to put down for the homework. This is the answer. Once I've distributed that term through, that's the answer that I'm looking for, right? Distribute, okay. Push the term through, multiply it by each of the things inside the parentheses. What might be helpful for us to know are these rules that are sitting over here on the right then as we go through and do more expressions. So these 3 rules are rules you should have seen before in your algebra career. If I'm multiplying two things together, x to the a times x to the b, and notice that the bases are the same. Right? The bases here are the same. So if I'm multiplying things together the same base, I'm going to add their exponents. And if I'm dividing things together, right, dividing things that have the same base, I'm going to subtract their exponents. And if I'm raising to a power, I'm going to multiply those powers together. You've seen these rules before. I'm not going to spend too much time restating them. You can look at them as I go through these problems. When I come over here now to the next example, I have a slightly more complicated set of terms. But it's still my job to remember that I'm distributing that x to the 1/2 to both things inside the parentheses. So it's 3x cubed times x to the 1/2 minus 2 times x to the 1/2. We all know about commutativity of multiplication means I can do this multiplication first and leave the 3 off by itself. And when I do, I'm going to get 3 times x to the 3 plus 1/2. Because I add those exponents together, minus 2 times x to the 1/2. And that leaves me with 3x to the 7/2 minus 2x to the 1/2. And again, this is my answer here at the end. I've distributed that term all the way through. So, before I do this last problem, maybe you want to freeze the video and see if you can do it by yourself. So freeze the video at this point and stop, and then look and come back and see if my process matches your process. Alright, this time there's more terms on the inside, but that doesn't change the process. This x cubed has to be distributed to everything on the inside of the parentheses. Each term, and there's 3 of them, so I'm going to have to do 3 products at the end. So it's 2 times the cube root of x times x cubed minus x times x cubed plus 1 times x cubed. Let's do those last 2 terms first. This is just going to be an x cubed. We're going to have an x to the 4th here. And now I have to figure out, okay, what do I do with that 2 times cube root of x? Well, it's 2 times, and then I change this cube root of x to be x to the 1/3, so I can see the power, times x to the third. Same base, add the exponents, 2x to the 10 thirds minus x to the fourth plus x cubed. This becomes our final expression.